Okay, hello then, and welcome to my first distance learning video with you guys at South Devon High School. Dan's also making some of these lessons, albeit in a slightly different way, so make sure you let us know which one you prefer. No pressure, no competition, but you know, we will know. We'll see the numbers, we'll see the views, we'll see the likes. So our first lesson is forces. Hopefully you'll have already clicked through the PowerPoint presentation and familiarised yourself with it, but if not, we'll start at the very beginning and describe what a force is. So, very simply, a force can either be a push or a pull on an object. So if you think of a car, there are forces acting on it at all times. Okay. So you can have the push force of the car, which would be the engine, and we might call this the thrust. Whereas you have the force acting back on that, which in this case would be air resistance, or we could call that drag. Okay, so forces push or pull objects along, and there are lots of different forces out there. You can have contact forces, such as physically pushing someone, physically pulling someone along, things like friction, things like drag. Or you can have non-contact forces, which are things like magnets and electromagnetism. Okay. The units for our force is measured in newtons. Okay. After Isaac Newton, which is who all these laws are named after, the first of which we'll look at today. Okay. So these forces, we can use them to look at things called force diagrams. So objects like cars, like people, will have lots of forces acting on them. So if we think of a car, it's very similar to what I've just drawn. A car has forces acting on it. It might have 800 newtons of force moving it forward, okay, which would tell us, which would be my thrust. Okay, and at the same time it might have some force acting back in the opposite direction, say 100 newtons of drag. Okay, the fact that this force is bigger than this force means that my car would accelerate in this direction. Okay, the size of the arrows tells you which force is bigger than the other. So the fact that this arrow is bigger than this one means that this force is bigger. We can calculate the overall resultant force. So the resultant force is what's left over when you counteract any forces that are acting in opposite directions. So we would do 800 minus 100 to give my resultant force of 700 newtons. So these are nice and simple, just little ways of showing forces acting on an object. You don't always have to draw out a pretty picture like I've done. You could just as easily draw a square, and that could represent any object that you're asked to talk about. And it's not just objects moving side to side. Falling objects like this would have a similar thing. Falling objects, things that are being pulled down, they're pulled down by their weight, by gravity, and what's pushing back up on them is air resistance or drag. Okay. But it's exactly the same as this here. My arrows are still showing which force is bigger, which ones, and then we can use that to work out which one which direction my object would be moving in. Okay, good. So all of these force diagrams and all these different forces we can use to look at the first of Newton's laws. And Newton's first law is nice and simple. It's that objects with a resultant force of 0 have no acceleration or are stationary. Okay, which means that if there's no overall force acting on an object, it stays where it is or stays travelling at the same speed. So if your car has 500 newtons of force going this way and 500 newtons going this way, its acceleration equals 0. And that could be to say that the car is not moving at all, but more likely it means that it's travelling at a constant speed. So it's important to remember that as your speed increases, so does air resistance. If you've ever put your hand out the window of a moving car, when it's moving slowly, you feel a little bit of resistance, but at greater speeds, your hand will move back much further. You'll feel that you've got a much greater force of resistance there. Next time you're driving on the motorway, open the car window, you'll feel the difference. You'll feel that different air resistance. And this explains why objects have a maximum speed. You can keep increasing your thrust, you can keep making this number bigger, but as you do, the air resistance, the drag increases as well. And so, eventually, your car, your object can no longer go any faster, and you reach your top speed. In science, we call top speed terminal velocity. So terminal velocity is the maximum speed an object can reach. Okay, and it reaches this maximum speed because all the forces on it are balanced, and so you can no longer get any acceleration. All objects have to obey Newton's first law. So they all must have a maximum speed. Good. So the example that they always use in exam questions that you really need to know about is a parachutist, someone jumping from a plane, and the forces involved in that. And this is a nice example to think about, and in the PowerPoint there's a video of someone going for a skydive, going for a parachute jump, and you can see it taking place. You can see how these forces change, so make sure you watch that if you haven't already before we discuss this here. So I'm losing a bit of sunlight here as I do it, so it's getting a bit darker. So if we think up here in my aeroplane, remember for a few months ago when, well, beginning of the month even, when we could still all travel on aeroplanes. If you think of your aeroplane and someone going on a parachute jump and jumping from that aeroplane, when they first jump out of that aeroplane, there's not been any time for any air resistance, so all that acts on them, the only force acting on them, is their weight. There might be a really little bit of air resistance, but not very much at all, and so they accelerate quickly, and they accelerate towards Earth. As time goes by, as they fall a little bit more, that air resistance increases. Because remember what we've just said, as your speed increases, so does your air resistance. So as my person has fallen further, their weight has dragged them down quicker, their speed has increased, and so their air resistance must have increased. And these two forces then will balance, and people reach a maximum speed, their terminal velocity. Okay, so if you jump out of an aeroplane, you won't continually get quicker and quicker and quicker. You'll reach a maximum speed. That speed will be about 120 miles per hour, which if you hit the ground at 120 miles an hour, you don't do too well. So what we do instead is we open our parachute, don't we? So after a little while, we open our parachute, and my person now increases one of their forces dramatically. Okay. That means their drag, their air resistance is now very big, and so they slow down. Their weight stays the same, but they have slowed down. This is why on videos of people doing parachute jumps, it looks like when they open their parachute that they've flown upwards. They haven't at all. It's just they've suddenly hit the brakes, whereas the person recording is staying at their same speed. And so relative to one another, it looks like the person who's opened their parachute has flown up into the air. Okay, because they've slowed down, because drag has increased dramatically. After a little while, these forces balance out again, and your person, your parachutist, reaches a new terminal velocity. Your forces are balanced again. This is the new maximum speed that they can travel at, and it's a new lower terminal velocity. Okay. So it's really common to get exam questions on these stages here, which you can just about see all of, and that included in the PowerPoint is one of these exam questions to look at. You just need to be able to talk about how these forces change at each stage. There's loads of good stuff on Bite Size about this if you're unhappy with my doodles here. Okay. And finally then, talking of that exam question, we have my badly drawn version of it here, our graph, which is linked to these stages that we've just drawn out here. So the question included in the presentation and included in the quiz that I've attached to this lesson is all about these different stages. And for 4 marks, you just need to explain what's happening in each one of these stages. So in A, this is when we first jump out of our aeroplane. Our mass is big, our weight is big, sorry, and that drags me down to Earth. My acceleration increases, my speed increases, and so this line here shows my speed increasing. As my speed increases, my drag increases as well, until at B, I've reached my terminal velocity, okay? My two forces are balanced, and I'm not going to get any faster. Speed is constant. Newton's first law is obeyed. My acceleration is 0 because my resultant force is 0. All forces are balanced, and my parachutist would stay at this speed forever, except for the fact that over here at point X, they open their parachute, and so drag increases dramatically, weight stays where it is, and they slow down. As they slow down, air resistance gets less, and those forces balance out again until a new lower terminal velocity is established. Great. So that should be everything for my first lesson. Hopefully it wasn't too ropey. We can all only improve, can't we? It will only get better from here. Hopefully you're all staying safe out there, you're washing your hands lots, and you're making sure you keep a decent distance from each other at all times. Let me know what you think. Feel free to share this video to other people who are struggling at home, trying to still do some schoolwork, but please don't laugh at me too much. Thanks very much. Bye bye.